We are still on technique of integration, in particular, integration by algebraic substitution. And to recall, guys, so we say that this technique, integration by algebraic substitution, is the generalization of simple use of substitution. And this technique uses integrand, including the differential in terms of the new variable. Okay? So for instance, if you are given integral of f of x dx, you will come up with an integral in terms of new variable, let's say g of y dy, where f of x and g of y are related by some equation, let's say y equals h of x, with h of x part of f of x. Okay? So meaning you are going to replace a part of f of x by what? By y. And then after that, you're going to get the differential of y, which is in terms of x, and then try to replace everything in terms of x together with the dx in terms of y. Okay, guys? Normally, radicals are the problem why indefinite integrals hard to evaluate, no? And in case you have radicals and impossible or not easy to evaluate using basic integration, then you can have integration by algebraic substitution. You try. But of course, not all the time, huh? Because there are things that even though there are radicals, but it doesn't mean leading to algebraic substitution. Okay? So we're now on number 6. 5. I mean, number 5. We ended number 4 last time. So given the integral of z squared, square root of e to the z cubed minus 1 dz. So we're asked to evaluate this integral. Okay, so let's try substitution, algebraic substitution. So I think this radical, what makes it difficult to evaluate. So let that radical to be equal to x. No? So let x be equal to square root of e to the z squared. When you write your z, you put bar in the middle so that it will not confuse with the number 2. Minus 1. So let's square each side so that this becomes simple to deal with. So we have x squared, and that is equal to e to the z squared, then minus 1, no? Yan.
Sir, di mo pa Z cube?
Cube ba? Sorry. Yan, malabo na yung mata ko. Thank you. C cube. Okay, now, if in case you see mistakes now, every time I write things, you inform me ahead or at once. So getting the differential, we have 2x. Thank you for that. 2x dx, and that is equal to e to the z squared, z cubed, and then derivative of z cubed is what? 3z squared, right? No? And then derivative of negative 1, 0. So multiplied by dx because you want differential. I dz because the variable is z and dz. Okay now, guys? So this integral is equal to, in terms of x, becomes what? So z squared is equal to, together with the dz. So it is z squared dz. So let's solve z squared dz from this relation. So we have to divide by 3 e to the z z cubed. So dividing by 3 e to the z cubed each side, we get 2x dx over 3 e to the z cubed, and that is equal to z squared dz. Okay? Now, so this radical is simply x times z squared dz is equal to 2x dx over 3 e to the z cubed. But e to the z cubed is equal to x squared minus 1. So we get here. So from here, we now have this one. So connected here. So we get 2x dx over 3 times, what is e to the z cubed? That is x squared plus 1, right, guys? And this is equal to z squared dz. So let's now replace z squared dz. Again, z squared dz is equal to 2x dx over 3 times x squared plus 1. So this integral now is in terms of x. So let's see what basic integration or possible, what other technique of integration can work on this. So this is equal to, when simplified, integral of, I will preserve this integral. I was able to make a beautiful integral side. So we have 2/3, no? I think 2/3 we can move it out because that is a constant, and we will not be needing that inside. So putting the 2/3 out, and then x times x is x squared, then dx over x squared plus 1. So this is now integration of a rational function, no? Yan. So improper. If it is improper, you're going to divide first. No? By long division, we get what, guys? So, but we can do it in a shortcut way, no? You add 1 so that it becomes the same with the denominator, but you have to subtract 1 so that this is the same with the original x squared all over x squared plus 1. And then we divide x squared plus 1 divided by x squared plus 1, that is equal to 1. Then minus 1 over x squared plus 1. So this integral now is equal to, guys, what is that equal to now, guys? 2/3.
2/3 1
2/3.
minus ano po?
So 1 minus.
1 over x squared plus 1.
So how do we evaluate the first term?
Dx.
So how do we evaluate that? So that is integral of dx. So what is that equal to? What is the integral of dx?
X po.
And then what about the second term? What is the integral? Negative 2/3 times what? Dx over x squared plus 1. That is
Tangent po.
tangent inverse tangent of x, no? Plus c. But x is not our original variable, so we have to put it back in terms of z. So we have 2/3 But what is x, guys? Is square root of e to the z cubed minus 1. Okay? And then minus 2/3 times inverse tangent of x is again is square root of e to the z cubed minus 1. Then plus c. Okay? Any question, guys, with this problem? Okay, if no question, let's proceed to number 6. So number 6, we have integral of secant squared x dx over square root of tangent x plus 5, and then this square root subtracted from it 2. Okay? Okay. Yan. So let's start. Or any suggestion? Guys, do you have any suggestion with this? What do you think needs replacement? What part of the integrand needs replacement?
Square root of tangent x plus 5 po.
Okay, very good. So let y, because this is x, so let y. So we agree to have x, y lang, ha? So don't get away from that variable. So this is square root of tangent x plus 5. Squaring, we get y squared equals tangent x plus 5. But what is this differential of this? No? So we get on the left side 2y dy. On the right side, we have secant squared dx. So secant squared x dx, that's already in the expression inside the integral. So, and this is equal to, so let's see. What is that equal to, guys? We have, guys.
Y times,
So in the numerator, what is the numerator? What will be in the numerator?
2y dy po.
2y dy. What about in the denominator?
Y po. Y minus 2 po.
Y minus 2. Then, after that, what comes next? So, it's long division, no? The degree of the numerator is equal to the degree of the denominator. That is an improper rational function. So, let's divide. We can include 2y if you want. So, 2y. Yan. So, we have 2 y minus 2, then plus 2. Am I correct, guys? Y minus 2 plus 2 is y, no? Times 2 to y. Then divide by y minus 2. So this gives us 2 times, this is 1, so 2. minus, plus 2 over y minus 2. So times 2 giving 4, no? Am I correct, guys?
Opo.
4 over y minus 2. So this integral now is equal to integral of 2 dy. So I can put the 2 out, and then I will have dy. And for the second integral, plus 4. This integral, I can put the 2 out. So we have 2 dy, and then the second integral is 4. Integral of, what integral?
1 over y minus 2 dy po.
Or that is dy over y minus 2, no? Yan. For the first integral, we have 2y. What about the second integral? 4 ln of absolute value of y minus 2, huh? Plus c. Okay? But y is positive. Okay? Or 0. So, and it is possible for this, if y is, let's say, 0, the value of this, so meaning if tangent x is equal to 5, negative 5, because for tangent, it is possible for the value to be negative. Okay? So, possible to be 0. So, it means we need really the absolute value, no? So, absolute value is necessary. Let's put it back to its original variable. 2 times square root of tangent x plus 5. And then plus 4 ln of square root of tangent x plus 5. And minus 2. Then the last part, so we have plus c. Okay, that's it. Any question with that, guys?
Sir, question.
Yes.
So yung sa ano po, yung nag-divide kayo sa numerator,
Yeah.
ano po nakuha yung y minus 2 plus 2?
Y minus 2? Because I want it to be the same with the denominator so that I can easily divide.
Tapos yung plus 2 po.
Because I want it to be y, 2y. So I have to add 2 because this is already negative 2 plus 2, it is now 1 times 2, it is 2y. Okay? You have to maintain the numerator to be the same as 2y. So again, I put the 2 out and then I made 1y minus 2. But this is now 2y minus 4. So if I add 2 inside, so y minus 2 plus 2 inside is simply y. So that is the same with this y. Times 2, I have 2y. So there is no change in value in the numerator. Okay, guys? Now, if you can't do that, you can have the long division if you want. It's just a technique of dividing. For the case like this, you can add and subtract. If you can't manage to do that, do not do, of course. There you have an option, the traditional division. Did I answer your question, Iho?
Yes po.
Okay. Let me check the attendance. Let's now proceed to the next one. We have number 7. For number 7, which do you think needs replacement here? Guys. Any suggestion?
Square root of arc secant x minus 1 over x squared minus 1 po, sir.
Square root of, again, sorry, Iho. What's your name, Iho?
Serrano po.
What is your suggestion?
Square root of arc secant x minus 1 over x squared minus 1 po.
I think if you're going to include in the replacement x squared minus 1, arc secant x will lose its derivative, because the derivative of arc secant x involves square root of x squared minus 1. Okay? So, the way I see it, you have to replace only the square root of arc secant x minus 1. You do not have to include square root of x squared minus 1. Okay, Iho?
Okay po, sir.
Okay, so let me rewrite this integral. This can be written integral of, we have this integral. I love this integral. I was able to make a nice one. So I have to maintain that. We have square root of, in the denominator, let's start with the denominator. I think I have many things to write. When you're writing a fraction, guys, the technique so that it will be a nice fraction, think of which part of the fraction you're going to write many characters. So like for instance, I think I will write many characters in the denominator, okay? So, or possible, let's see, I can have here is square root. I think I need only square root in the numerator. And this is x together with square root of x squared minus 1 be part of the differential. So this is arc secant or inverse secant of x minus 1 over arc secant. Okay, then times. So for the differential of arc secant, we have x is square root of. So this is square root comes from this part, no? So I split this into two square roots in the form of quotient. One is here in the numerator, and then the one that is in the denominator, square root of x squared minus 1. Okay? So let y be equal to square root of arc secant x minus 1. Squaring each side, we get y squared equals arc secant of x minus 1. So let's get the differential. Getting 2y dy. On the right side, we have actually this one, no? Let's just copy that. And this part. Am I correct, guys? Guys, am I correct?
Yes po.
So let's put it here. And that's the differential of arc secant. Derivative of negative 1 is 0. So the differential is 0 also, no? So we now have 2y dy equals dx over square root of x squared minus 1 and then multiply outside by x. Okay, that is square root. So let's proceed expressing the given integral in terms of y. I have to copy this integral sign. And here we go. Okay, guys. Make it go. Oh, this part is y, no?
Y.
What about the denominator?
Y squared plus 1 po.
Y squared plus 1. You notice that almost the same with the previous, no? The after substitution, we get a form that is almost the same with the previous ones. And this is
2y dy.
2y dy. Okay, 2y dy. And I think we answered this already. Here? Ah, no, no. I think the previous one. Similar here, no? Right? This part, except for 2/3. Am I correct? Yeah. So, putting the 2 out, we have 2 integral of y squared dy over y squared plus 1. And this integral, as what we had before, is the same with what, guys? Integral of, guys? Huh? dy, no? Remember dy? Is it plus or minus, guys? So we have y squared plus 1 minus 1. So minus, there we have a multiplier 2. Okay? Integral of dy. So plus 1 minus 1. So 1 plus 1 minus 1 times 2 here. Y squared plus 1. Am I correct, guys? Do I have to write that? Y squared plus 1. And then let's retrieve it. Minus 1. So that we'll able to retrieve or maintain y squared over y squared plus 1. So this is equal to 1. This is minus 1 over y squared plus 1. Then times 2 each. So we now have 2y minus 2 arctangent of, let's choose arctangent because this is arcsecant to be consistent with the notation. Arctangent of y. Okay? But what is y, guys? Arcsecant of x square root minus 1, no? Square root of arcsecant of x minus 1 minus 2 arctangent of square root of arcsecant of x minus 1, then plus c. A question, guys? Guys? So let's see if there is one more. I think this is the last one. What about this? Any suggestion? Alcantara? Chuapoco? Behar? Conti? Diasis? Domingo? Escareces? Gabriel? Galang? Gonzales? Heluya? Navajas? Guys? Guys, do you have any suggestion with this? Guys? So you have here 1 and what? 2 and 4. Or what is the LCM of 2 and 4? This common multiple of 2 and 4.
4 po.
4, no? So we let x, or let's say let x be equal to fourth root of, fourth root of z. We did not include 3 because there is no 3 in z in the square root. Okay? And then the least common multiple is 4. So in that way, we will able to, once we get the square root later, it is exactly, that the exponent of for x is an integer. Okay? So that's raised to 4 each side, x to the 4th. Then the right side is simply z. So getting 4x cubed dx. And on the right side, we have dz. Okay, guys? This is equal to, so what's the integral?
Integral of 4x cubed dx po over
Okay, thank you. So integral of, the denominator. So what is square root? So from here, if I solve for square
x
root
squared
of
po.
z, so x squared, no? That is square root of z. What about fourth root? So if I have fourth root, that is x to the fourth, no? Sorry. If I have fourth
X
root,
lang po.
it is simply x. Yan. So actually, it's already there, no? No need to solve. So square root of z, that is x squared. Fourth root is this, no? That is x. But I have to cube it because it is cubed. Okay? Again, x is the fourth root of z. But it is z cubed. If I cube this, I have to cube the x. Am I correct, children?
Yes
Guys?
po.
So in the numerator, we have 4x cubed dx. So this is now in terms of x. So everything is in terms of x. So let's simplify this. Integral of, what is that equal to, guys? I can factor out x squared, no, in the denominator, giving x squared, then 1 plus x. Okay? In the numerator, I can have that as 4x squared times x dx. So I can cancel out x squared, no? X squared canceled out. So getting this integral. So this is we have 4 put the 4 out, then inside, wait a minute, I'll adjust this integral. So we have 4, put this 4 out, then x dx, no? X dx over 1 plus x or x plus 1. And we did this already, no, before. So x plus 1, what is to be subtracted, guys? 1, no? All over x plus 1. Getting 1 minus 1 over x plus 1. So this is equal to 4. Integral of dx. Okay, guys? So this is dx minus 4 also. Then dx over x plus 1. Oh, anyone who wants to give me the integral of these two integral? These two integrals, guys.
4.
4x po.
For
X.
for x, no? What about the second integral?
Minus 4 ln x plus
ln
4
of
ln of x plus 1 po.
x plus 1. I think no need for absolute value because x is always greater than or equal to 0. Okay, as you'll see here, for any chosen z that is valid, ang valid chosen silang ay mga positive number or 0 kasi for truth o hindi mag-negative ang x. A plus 1, so guaranteed never negative. Therefore, no need for absolute value. Pero kung nalagay nyo sa inyo, okay lang. But what is x, guys? So, fourth root of
4th root of z po.
z. And then, minus 4 ln of, yan, fourth root of z. Plus 1 plus c. Okay, that's it. Okay?